This video is going to cover section 6.2, place value systems. Okay, so this one actually has a lot of information. I went ahead and copy pasted a lot of the material just to kind of go through it because otherwise this would be a very, very, very lengthy video. Okay, so just before we start, let me go ahead and tell you what kind of system we're talking about um, by using the one that we use. So the one that we tend to use is the base 10 system. And the way this one works is like so. You start with 10 to the power of 0, 10 to the power of 1, 10 to the power of 2, 10 to the power of 3, 10 to the power of 4, and so forth. You get the idea. Okay. And what we're doing is these numbers are the same as the following. So 10 to the power of 0 is 1. Remember that anything to the power of 0 is equal to 1. 10 to the power of 1 is 10. 10 squared is 10 times 10, which is 100. 10 to the third power is 10 times 10 times 10, which is 1,000. And I believe this one just adds another 0 and it just keeps on going. Okay. So the reason I think we decided to adopt this is because if you notice, the pattern just keeps adding zeros. So it makes it a lot easier for us to deal with when adapting this to actual numbers. Okay. So one way to kind of see this in action, let's say you had the number um, 234. Okay. And you wanted to write this in terms of powers of 10. We kind of did this in the first section, 6.1. You can do this as 2 times 100 plus 3 times 10, okay, plus 4 times 1. And you can see that we are using our powers of 10 here, okay. This right here, that what I just did, this is called the expanded form, okay. And actually, we can even go even further. We can say that this is the same as 2 times, instead of 100, I would say, and actually, let me write it the way the book has it. So it'd be 2 times 10 squared, because that's the same as this one right here, plus 3 times 10 to the first power, because that's the same as this one, plus 4 times 10 to the 0. Again, because 1 is the same as 10 to the 0. So this right here would be our expanded form, okay, all the way to the end. And so for the first part of this section, we discuss the one that we're familiar with, okay? And then using this, we're going to kind of expand into Babylonian and Mayan numeration systems. Let's go ahead and look at an example. Okay, this one says simplify all of this. So what I'm going to do is I'm going to first rewrite all of my powers of 10. So all of these in something that's more familiar. So kind of going backwards from what I just showed you. Okay, so my first step would be 2 times, let's see, if I'm going to have 3, that would be 1, 2, 3,000. Okay, plus 7 times 100, because we have 10 to the second power. Okay, so 2 zeros. Plus 6 times 10 to the first power is just 10. Okay, and then plus 3 times 1. So all of these are like our second step in expand in going backwards and simplifying this. Okay, from here we can go ahead and actually multiply it. So we know that 2 times 1,000 is 2,000. Okay, 7 times 100 is 700. 6 times 10 is just 60. And 3 times 1 is 3. And then finally, from this last step, we can just combine everything. So this would be the same as 2,763. And that's it, simple as that. Okay, but if you get this premise, you should be able to do some of the next problems. Or we're going to do one more actually. So I encourage you to try this one by yourself first, and then you can check to see if it's correct. Okay, so this one looks like we have 5 times 10,000, so we have 4 zeros now. Okay, plus 9 times 1,000 plus 2 times 100 plus 7 times 10. Oh, I don't want to put those parentheses. Trying to keep it consistent. So 7 times 10, okay, plus 4 times 1. Okay, and then we go ahead and multiply this out. So this would give me 50,000 for this first one, plus 9,000 plus 200 plus 70 plus 4. And ultimately, if I add all these up, I get 59,274. Okay, that's it. Let's move on. So we're going to use this expanded form to add numbers up now. Of course, you can always check this using your basic addition rules. So we have an example here, and I actually gave you the solution just so you can kind of see how it works. So pretty much we know that 26, okay, 26 right here is 2 times 10 plus 6 times 1. So they didn't put the 1, but it's, 6 times 1 is just 6. 30, excuse me, 31 is the same as 3 times 10 plus 1 times 1. So the way it works is they added the 2 and the 3 to give me the 5, and then the 6 and the 1 to give me the 7. Okay, 5 times 10 is 50, 7 times 1 is 7, and 50 plus 7 is 57. Okay, so it's kind of like what we did in the unit before with all of the Egyptian hieroglyphic symbols. Okay, so we're going to go ahead and try another example here. Okay, so we already kind of have a setup. It says find the sum of 85 and 57. So I'm going to go ahead and add these two numbers first. 8 plus 5 is 13. I'm going to bring all this down, 13 times 10. And I guess for the sake of consistency, we don't have to put that times 1 for these ones, okay? So 5 plus 7 is 12. So we have plus 12. From here, we can kind of do this two ways. We can actually expand this part right here and say, well, this is the same as 3 plus 10 times 10, or you can just multiply it out. I'm just going to multiply it out. That's okay. So 13 times 10 is 130, okay? Plus the 12 that we have here is equal to 142, okay? And if we wanted to check it the way we're used to, well, 5 plus 7 is 12. Carry the 1. 8 plus 5 plus 1 is going to be 14, 142. You see how it does match. Okay, moving on. So we have an example of subtraction here. So this one, I went ahead and just copied the whole thing because, like I said, this particular section of the unit is a lot of material. Okay, so I'm going to go through each step, and if you need more examples, just let me know. I'd be happy to help. So here we have, we're gonna use the expanded forms of 457 and 283 to find the difference, 457 minus 283, okay? So we start off with the numbers and you start by expanding. So 457 is the same as 4 times 100, because that's the 100, plus 5 times 10, because that's the tens place, okay? And then 7 times 1. Notice that for the ones place, they're just putting the actual number, okay? So there's the 7. Okay, same thing with the bottom. Excuse me, had to sneeze. So for the bottom, we have 2 times 100. So there's my 100 again because it's in the hundreds place. And then we have the tens place is an 8. So there's my tens place. And there is the 3. Okay. And then just like before, we're going to kind of combine, but because we're subtracting, okay, but we're subtracting in this one, you got to be careful because if you have the bigger number on the bottom, you're going to have to borrow, okay? So if you notice 7 and 3 are fine, but this combination right here, 5 and 8, you can't take away 8 from 5 because there's not enough for this one. So we're going to have to do here is we're going to have to borrow, okay? We're going to borrow from the hundreds place. So just like we would in regular subtraction. So from the hundreds place, which would be this 4 right here, okay? So if we take away 4, I'm sorry, 4. If we take away one of the hundreds from here, it would be like saying 4 minus 1 is 3. We're left with 3. So the 100 that we took away, okay, so if we take away 100, this is the same as 10 times 10, right? So it's like we're going to be adding 10 more to the tens place, if that makes any sense. Okay, so we're actually doing, so the one that we took away is this one right here, the 10 times 10. That's why I wrote it out over here. But we still have the 5 times 10. So what we do is we add them. We say, well, 10 plus 5 is 15. Okay, and just keep in mind that now we only have 3 left over here because we took away one of the hundreds. So with that in mind, we rewrite this. Okay, so now we can say that this is equal to, well, instead of 4, I have a 3 now because we took one away. And now I have the 15 that I needed to get rid of the 8 down here, and everything else stays the same. So from there, I can go ahead and subtract. So 7 minus 3 is 4. 15 minus 8 is 7. And 3 minus 2 is 1. Okay, then you just combine it. So 1 times 100 is 100. Okay, 7 times 10 is 70. 4 is just 4. Add these up, 174. Okay, so just keep in mind that if you don't have enough, you can always borrow. And that's the reason why when you do regular subtraction, so if you were to do this subtraction here on the side, just normally, like from grade school, okay, 7 minus 3 is 4. Here we don't have enough, so we have to borrow. So you see how that became a 3, just like it became a 3 over here. And this is now 15, just like the 15 we had here. 15 minus 8 is 7. 3 minus 2 is 1. There you go. Okay. All right. So we're going to go ahead and move on. Like I said, there's quite a bit to cover in this particular video. So let's move up. I believe we have Babylonian systems next. Yes. So we have this system called the Babylonian numeration system. And this was used by the Babylonians. Okay. So unlike ours, they did use the place value system, so that kind of stays the same. However, their place system is not by tens; it's actually by 60s. So, and there's a reason for that. If you'd like to look it up, I definitely recommend reading about it. Okay, they use powers of 60. So remember, ours was 10 to the 0, 10 to the 1, 10 to the second, and that was the same as 1, 10, 100. So we had that pattern going, but they did not use that. They used 60. So we're going to actually have to multiply that out and see, well, what is 60 to the second power, okay? But so here's kind of how it works. 60 to the 0 is still going to be 1 because anything to the power of 0 is 1. 60 to the first power, this is like saying 60 by itself, so it's still 60, okay? 60 squared is 60 times 60. So if you multiply that out, you get 3,600, okay? 60 to the third power is 60 times 60 times 60, and that gives us 216,000, and it just goes on. So the next one would be 60 to the fourth, and so forth. Okay, so keep that in mind. We're going to be multiplying by these place values. Instead of multiplying by powers of 10 like ours, we're going to multiply by these ones now. Okay, second thing to take note of is that they didn't use numbers exactly, they used symbols. So their symbols were used with a wedge-shaped stylus, where if you pressed it vertically down, you got this kind of like an eye looking thing, or I don't even know, I guess an upside down triangle, you could say. And this represents a 1 unit, okay? The sideways one, which is kind of just a little bit more like a bird, I guess, or I don't know, but it's a sideways V looking thing. This is the 10, okay? So we're going to use that for this one. And here's how it's going to work. Okay, so I'm going to go ahead and just keep that part shown. It says, write this as a Hindu Arabic numeral. Remember that the Hindu Arabic is just these are the ones that we use. Okay, so before I do anything at all, I'm going to write these in terms of this right here. So this is just one because it's just one of them. I have 3 of the sideways V's. So remember, those are tens. So 10, 20, 30, and then 1. So that's 31. Okay. Here I have 2 of the V's. So that's going to be 20 and then 5. So 25. Oh, I forgot to take note that the Babylonians, the way they separated their numbers was with spaces. So if you have a space in between here and in between here, that's how you would identify where your place values are going to go. Okay? So now what we're going to do is on top of each one, starting from the left, I'm sorry, from the right, we're going to put our place values. This would be 60 to the 0, 60 to the first power, and 60 to the second power. Okay? And what we're going to do is we're going to multiply each of these together and then add them up. So this is what it would kind of look like. Okay? I would have 1 times 60 squared. Okay, that's this one, plus 31 times 60 to the first power. That's going to be this one. So let me make it a little bit more combined. There you go. So that would be that one. This would be the first one. Okay. And then the last one would be plus 25 times 60 to the 0 power. So this one would be together. Okay. And then from there, we just have to work this out. So 60 squared is the same as 3,600. So you're thinking 1 times 3,600. Okay. Plus 31 times 60 to the first power is just 60. So that one's nice and easy for us. And then the last one plus 25 times, remember that 60 to the first power is just 1. So that one's even easier. Okay, still going step by step here. 1 times 3,600 is 3,600. Okay. 31 times 60. Oh, that's kind of a big number. Let me see. Plus, we have the 0. 1 times 6. 1860. You can double check that if you'd like. Okay. And then we have plus 25. And I believe at this point we could probably just add it all up. Okay. So let's see. We have 5. I'm just doing the math in my head right now. Okay. So 2 plus 6 is going to give me 8. And then we have 8 and 6. It's going to be 14. Carry the 1. 3, 4, 5. So I'm getting 5485. I think that's correct. Let me just double check. I don't have these memorized exactly. Yeah, that looks about right to me. Okay, so this would be our answer. Okay, so let's go ahead and we're going to do another one, I believe, and I think this one might be shown. Okay, so this one it's the same style. We're going to go ahead and do what we did first, where we write the numbers on the bottom. So remember that the sideways are the tens. So this would be 21. Okay, this is just a bunch of ones. So 1, 2, 3, 4, 5. So we have 5 here. 1, 2, 3. So that's 30. 1, 2, 3, 4, 34. Okay. And just like before, we have the powers of 60 on the top. So 60 to the 0 power, 60 to the first power, and 60 to the second power. Okay. And we're going to multiply just like we did before. So we're going to have 21 times 60 squared. That's this one. And then we're going to have 5 times 60 to the first power. So plus 5 times 60 to the first power, okay, plus this last one, plus 34 times 60 to the 0 power. Okay, so this is the same as 21 times 3,600 plus 5 times 60 plus 34 times 1. And then we multiply this out. This one I did multiply ahead of time because that's a big number. So 21 times 3,600 came out to 75,600. Okay. Plus 5 times 60 is just 300. Oops, that's a plus. Okay. And then 34 times 1 is just 34. So when we add all this up, we get, let me see, 75,934. 75,934. Okay, that's it. Now, This part is not too difficult, but what happens if you have to go backwards? So that's where it gets a little bit interesting. Okay. It says write 8503 as a Babylonian numeral. So this is a little bit more difficult because you have to remember that these are in powers of 10. So you can't just say, oh, it's 8 times 1,000 plus 5 times 100. That 1,000 and 100 that I'm mentioning, those are not powers of 60. Okay. So it makes it a little bit more difficult. So here's how the way you would do it in our system is you would divide by the powers of 10 and say, well, it would be 8503 goes into 8,008 times, and then it goes into whatever's left over 5 times, and so forth. So it's the same concept here. So it helps to have the actual powers. These are the powers 60 to the 0 to the 1 to the second, third, and those are the same as these down here. So like 60 to the first power is 1. I'm sorry, 0 power is 1, 60 to the first is 60, that one's here, and so forth. Okay, so what we're going to do is we're going to say, well, where does this number fall? So 8503, which of these numbers down here, so these numbers, goes into 8503 without going over it? Okay, so, well, 1 goes in for sure, 60 goes in for sure, 3600 goes in for sure, 216,000 is way too big. So we're going to start with 3600. And we're going to divide this number by this number. So you can see that right here. We have 8503 divided by 3600, and it gives us 2 with a remainder of, so this is our remainder right here. Cannot write that remainder of 1303. Okay, that looks horrible. Let me just write that a little bit nicer. So this is our remainder down here of 1303. So what does this mean? Well, this means that for sure we have 2 of these, 2 of the 3600. So we have 2 of the 60 squares. Okay. Now, after that, we have a remainder of 1303. So that's going to go into our next power. So the power that comes after or before this is now 60. So we do the same thing. We divide 1303 by 60, and then they did the division for us, and it gave us 21 with a remainder of 43. Okay, so that means that we're going to have this plus 21 powers of 60 to the first power. Okay, so far, I hope you can see how we're going backwards from here. And now at the way end, we have 43. Well, 43 doesn't really go into anything, so it's just going to be the 1 right here. So it would be plus 43 times 60 to the 0 power, which is the same as 1. Okay, and then we just multiply it out like we did before. So oh, but actually, no, I want to go Babylonian. So from here, you can actually just write everything out. So I would do, let me see what color I want to use. I'll use this one. So for Babylonian, remember you have the tens place, okay? I'm sorry, the ones place would just be 1. Those little like triangle, upside down triangles. And that would be the first place value here, okay? 21 is going to be your sideways, almost like a boomerang looking thing, okay? So there's 20 and then the upside down triangle. So there's 21, okay? And then 43 is going to be 4 of those. So 1, 2, 3, 4, and then the upside down triangles. And just because of the way these are spaced, you should automatically know that the first one pertains to the 60 to the 0, the second one is 60 to the 1, and the third one is 60 to the second power. So really what we need are these numbers here. Okay, but yeah, this was your answer. And I think we're almost done. Yes, we have 2 more examples, guys. Hang in there. So now I'm going to show you how to find the sum. The sum is really similar to what we've already been doing, where you just line them up and add them up. Okay, so if you look here, we have the 60 to the first power here in the leftmost column and 60 to the 0 power in this column. And we're just going to add everything up. So the symbols just kind of follow down. Okay, so they're lined up the same way. And you can see that in this first part right here, we had 1, 2, 3, 4, 5, 6, 7. So now I have 7 of them here. And then we had 1, 2, 3, 4, 5, 5 of these here. Same thing over here. So 1, 2, 3, 4, 5, 6. So there's 6. 1, 2, 3, 4. 1, 2, 3, 4. Okay. Now remember that whenever we have 6 of these things, that would be the same as 60, right? So this is technically another power of 60. It's a power, it's another one. It's I should say plus 1 power of 60, which means that if we have another power of it, we can actually move it up to the next level, up to the next place value. Okay, so that's kind of what happened here. Okay, so you can see, let me kind of color code this a little bit, that we have 6 of them here. 1, 2, 3, 4, 5, 6. So these 6 right here, if you look on the next step, they got transferred over to become one of these guys now. Okay, and they move up. Then it even tells you here, take away 60s from the ones place and add 1 to the 60s place. So now it goes up to the next unit place. Okay, same thing over here. We can see that this one has 6 of them. Let's see, 1, 2, 3, 4, 5, 6. So now this guy moved up to become a 1 on the next level. Okay, and then from there, we can just bring it all down. So we have that this guy right here is our first one. Okay, so now we have 60 to the square power here. Then we have our 4 guys here. So that's these guys right here. That's 60 to the first power. And this what I'm adding here is just kind of extra. Okay, you don't have to, it's not really asking us for that, but just so you know, and this would be 60 to the 0. So this right here would be our answer. Okay. And last but not least, the Mayan numeration system. So this one I'm going to go through fairly quickly. I know there's a lot of systems, and I think if you read your book, there's a couple that are in Chinese as well. So yay for other languages and different symbols. It is important, guys. Math is the universal language after all. So here we go. This one has a very unique system. So they use their system is based on their calendar, which I'm not going to go too much into, but pretty much it's divided into a calendar of 300 and I believe 64 points. I want to say 0.24, something like that. 365.24. And they use 18 months of 20 days. So it's yeah, a variation of our own calendar. And the way theirs works is by the following table. So their first one is 20 to the 0 power, which is just 1. Okay, 20 to the first, which is 20. And then they start multiplying times 18. So 20 to the first times 18, which is 360. 20 squared times 18, which is 7,200, and so forth. Okay, so just keep that in mind here. And then we have the table and what these look like. So the actual numerals are not that difficult because they kind of follow a dot line system where a dot is kind of like a 1. It's a it's a 1 unit. I guess you could think of it that way. And then the line is equal to 5 units. Okay, so you can see that here. And then they do have a symbol for 0. So 0 is the one that looks like a kind of like an eye. They call it a shell. Okay, but 0 does have a distinct number. And this, I believe, this is kind of where we got our own with the Hindu-Arabic. The Mayans were one of the first civilizations to actually use a placeholder for 0. Okay, so just important facts, I guess you could say. So anyway, you can kind of see, I'm not going to go through each one, but let's just say 14, for instance. You have the two tens, so I'm sorry, the two fives, so it's 5, 10, 11, 12, 13, 14, and so forth. Okay, so let me go ahead and go into an example or a couple so you can see how this works. I'm going to leave that part right there so you can see the 1 and the 5. We want to write each of these as a Hindu Arabic numeral. So one thing to note about these is they did these vertically to kind of show you where the place value is highest. So the highest level, so this one right here, this would be your highest place value in this column of 3 elements, okay? So before we do any of that, let me go ahead and let me start writing this out. So A has those 2 lines and it has these 3 dots and a line and then a dot and 2 lines. Okay, so the first thing I'm going to do is I'm just going to write the number. So this is the same as 10 because there's 2 5s. Okay, this is the same as 8 because it's 5 and then 3 dots. And this is the same as 11 because it's 2 5s and a 1. Okay, from here, we're going to go ahead and multiply each of these by its corresponding uh, base power. So that means that the top one, and we can refer to our table over here so you can see what I'm talking about. There's three of them, so I'm going to cover 1, 2, 3 here, but I'm going to look at the part that's down here because that's easier. So I'm going to multiply this one, that bottom one, so I can get this all on the screen, times 1, the second one times 20, and the third one times 360. Okay, and that's kind of it. We just have to multiply it out now. So this would be, let's see, 3,600. 8 times 20 is 160. 11 times 1 is 11. And then we just add this all up. Okay, and we get, let me see, 7, 7, 3771. Okay, and yeah, letter B pretty much works the same. I think for this one, I'm actually just going to give you the answer, and I encourage you to try it. Remember that this one is equal to 0, okay? So for B, if you do try it, you should get 36,243. Also because this video is already extremely long. So that's it. Let me know if you have any questions.